What you're looking at here can seem a bit daunting at first because you've got many different components. So I'm going to use a pencil to point out the different components and then just hold up a circuit diagram to try and make sense of the circuit. Okay, so firstly at the top we've got our 12 volt DC power supply. That is this component here. Mr. Hancock, if you could just hold that up please. Okay, so here's our power supply, and if we trace out of the power supply, we go along this wire, we then go straight into our ammeter, which we see here. Remember the symbol, I have a spare ammeter to the side here, and that's the symbol for the ammeter. We then, if we trace out underneath the ammeter, we then go to the component under test. Now in this circuit diagram, yes, we have a bulb or a lamp. We are going to be using a resistor, and you can see the symbol for a resistance there. So we come out of the power supply, through the ammeter, through the resistor. Don't worry about these wires for the moment, which go to the voltmeter. So we're going through the bulb, or in our case, the resistor. And the symbol for the resistor is that rectangular shape. We carry on and then we get to our variable resistor. So our variable resistor is just here, and the variable resistor is something that allows us to change the voltage across and the current flowing through. So as Mr. Hancock is demonstrating beautifully there, you can slide the slider both ways and that will vary the voltage on the voltmeter here and the current on the ammeter here. So what we need to do is change the voltage across the resistor and measure the current through it. And what you need to do then is, in your booklet, I'll just hold the booklet here, we are going to be recording the voltage and the current here. We're going to take 6 readings going down, and then you're going to calculate the resistance in this final column. And what we should find is that the value for the resistance here should be approximately the same. Then underneath the table, of course, you're going to be plotting the graph. Notice the graph has got both a positive and negative axes. So what we'll do in our table, we'll take some positive voltages and some negative voltages so that we can plot both sides of the axes. Okay, so we are currently, if you look at the voltmeter here, and I'm just going to move that wire out of the way, we're around about 1 volt. It's fluctuating slightly, but it's as close as we can get it to 1 volt. And the ammeter is reading, if we move the camera around, move that wire out the way, is reading 0.2. So what we're going to enter here on the table, at 0 volts we get 0 amps, but at 100 volts we are getting 0.20 amps. And if you divided the voltage by the current, and I'll do the first one with you, if we hold this up here, you would divide voltage by current, 1 by 0.2, and you would write 5 in there. But we're not going to do those during this part of the video. Okay, we're now going to change the voltage to 2 to 3, and then negative 1, 2, and 3, and take the results. So Mr. Hancock now is just moving the variable resistor. Great work, sir. He's got that at 2.01. So I'm going to be writing that value for voltage now into the table, 2.01, and the current is 0.43 3, and I'm going to hold that table up to the camera as Sir then changes the voltage to as close as he can get for 3 volts. So you make sure now you copy that down into your booklet. And that's great, sir. We've got there 3.00. Yes, it's fluctuating again. And the current is reading 0.67. 3.00, 0.67. Okay, so we have got a value of 3.65 and 0.82. So I'll write that down, 3.65, 0.82. And we're now going to take some negative readings. Hancock now has kindly changed the polarity on our power supply. Remember, that's our variable DC power supply. And you'll notice straight away, as Sir's pointing out, and I'll just move here so we can see, that the readings now have become negative. You can notice there's a little negative or minus sign just in front of the values on the meter and on the ammeter. Remember, voltmeter in parallel, ammeter in series. So what we'll do this time, we'll actually start, Sir, perhaps at that value there, minus 4. We'll call it minus 4.28. And we've got minus 0.96. And then Sir's going to move it down to somewhere close to 3 volts, minus 3 volts I should say, and minus 2 volts. Hasn't got to be spot on, but we'll get as close as we can. It's jumping about a little bit. Okay, let's leave it settle there then, Sir. We've got minus 3.42, minus 3.42, and we've got minus 0.76. And we'll take one final reading. As Sir's doing that, I'll just show you the table, which you need to have in your box. And here we've got one final reading. Oh, well done, sir. We've got minus 1.99 and minus 0.45. Okay, so what you need to do now is use those values we have there, fill in the third and final column for resistance, and then plot a graph of voltage against current. Remember, independent variables go on the horizontal axis, so that's voltage on the horizontal, and current is what's being measured. We're changing the voltage, we're measuring the current, so current will be on the vertical axis. And what you should get is a straight line graph that goes through the origin here, because when your voltage is 0, the current is 0. So you should have a straight line graph going through. Now, just before we finish, let's look back at this circuit again. We could have very well done exactly the same experiment and just change the component under test. So we could just change that fixed resistor for a different component, in this case a bulb. Ooh, we're at minus 7.3 volts, sir. I might blow the bulb. Can we go down, perhaps use the variable resistor, fine. If we go down below 6 volts, then that bulb should come on. And again, we could do exactly the same experiment. We could change the voltage as Sir's changing the variable resistor now. You can see as the voltage is changing across the bulb. Right, so it's minus 3.36 going down. You should see the ammeter on the right hand side which is 0.04 at the moment, or minus 0.04, changing as well. It's just dropped down to minus 0.03. There's three different components you need to learn the shape of. When I say the shape of, the VI, or voltage current graph, it's a straight line for a resistor, it's a curved shape for a bulb, and the shape for a diode is characteristic that it goes along the horizontal axis and then a sharp increase at the threshold voltage. Look at that later.